Hello everyone. Today we will introduce the basic operations on continuous time signals. The time reflection operation can be expressed using XO minus t. That is, flipping the signal about the origin. Here is one example. The time reflection version of this signal can be shown in this figure. The time compression and extension operation can be expressed using XOA times t. When a is larger than 0 and less than 1, it corresponds to time extension. When a is larger than 1, it is time compression. Here is one example. For these signals, XO2 times t can be obtained as this figure, that is, compress this signal by 2 times. XOT over 2 can be obtained by extend this signal by 2 times. The time compression and extension operation can simulate the signals played faster or slower. Let's listen to these 3 audios.
对了。
We can find that the faster corresponds to the time compression and the slower sound corresponds to time extension. Time shifting operation can be expressed using this formula. XOT minus t sub 0 is shifting the signal to the right by t sub 0. XOT plus t sub 0 means shift the signal to the left by t sub 0. Here is one example. The XOT minus 1 is shifting the signal to the right by 1. XOT plus 1 is shifting the signal to the left by 1. The time shifting operation can simulate the signal delay in telecommunication. Now let's give an example. Here we give the waveform of SOT. You should plot the freeform of this signal. Now let's give the solutions. We first do 2 times compression on this signal and we get XO2 times t. And then we do the time reflection operation and we get XO minus 2 times t. Finally, we shift this signal to the right by 3 and we get the final result. Now let's give a new method for the combined operation, that is, invariant function values at terminals. We can find that time reflection, scaling, and shifting are linear changes on the independent variable. These operations will not change the function's values at the terminals. For example, here we give the waveform of SOT. The minus 2 is one terminal for this signal, and we can get 1 terminals for this signal can be expressed using this equation, and we can get T11 equals to 4. 3 is another terminal for this SOT, and we can get the new terminals for this signal can be calculated using this equation, and we can get the terminals equals to 1.5. Thus, we can get 2 terminals for this signal, and we can finally get the result. Now, let's give the generalized form for this method. Here, T1 and T2 are 2 terminals of SOT, and T11 and T22 are 2 new terminals for these signals. These two terminals can be expressed using these two formulas. The invariant function values at the terminals method is very effective solving these problems. For these signals, -2 and 3 are two terminals. Here, the terminals for these new signals can be calculated using these two equations, and we can get the new terminals as 5 and -2.5. Thus, we can get the final result for these signals. Now, let's give another example. In these signals, it has one impulse signal. Thus, when we do the scaling, you should use the scaling properties of delta t. It should be noted that the strength of this impulse signal is changed from 1 to 1/3. Now, let's do a summary on this lecture. In this lecture, we introduce some basic operations on continuous time signals, including time reflection, time compression, time extension, and time shifting. You should notice that for these operations, they are linear changes on the independent variables, and they will not change the function values at the terminals. Based on these principles, we give a new method for the combined operation, that is invariant function values at the terminals. That's all. Thank you. See you next time.